All right. For those of you on YouTube, I'm sorry. I started recording and then realized I did something wrong, so I had to come back. We just looked at an arithmetic sequence. The example I gave you was 1, 4, 7, 10. An arithmetic sequence means that we're adding or subtracting in order to get to the next term. So this time, the thing that we're adding or subtracting is 3, and so we call that the common difference. What I was just about to get ready to say was the formula for this. So we call this the explicit formula. Explicit just means, you know, as like straightforward as you can get. There's a lot of terms here, so let me write it out and then I'm going to talk about it. So it goes a sub n, which I read as a sub n. That's what I said, to do a with this little n underneath it, equals a sub 1 plus n minus 1 times d. A sub anything, so of 1 or n or 2 or 20 or 90, a sub anything means that's what number term we're looking at. So like in our case, this a sub 1 means that I'm looking at the first term. D is my common difference, which we just looked at a minute ago. And then n is the number of term that we're looking at. So if I say I want to find the 5th term, then we're going to plug a 5 in for both my n's. If I want to do the 97th term, I'm going to plug 97 in for my n's. And then a sub n just means the general nth term. So I don't know which term that is. It's just the nth term. I know this is a little different for you guys, but it's pretty straightforward once we go through a couple of them. I'm going to jump down and we're going to go down to 1a and we're going to do the type of problem it is, give its difference or ratio, and then give its explicit formula. We are not going to write recursive formula for right now, just for sake of timing this year. I might do that with the juniors. We are going to look at a recursive function, but we're not going to write it. So first thing I noticed, I haven't taught you another type, so this has got to be arithmetic. So what am I doing to get between each term? What am I doing each time? Plus 4. Good. So my D, my common difference, is positive 4. It's arithmetic because I'm adding or subtracting, not multiplying or dividing. You don't know that yet. And we're going to write our generic form for this. So again, if you remember, our formula is up here. So I'm going to write a sub n, because that's my general term. I don't know what term it is. What's my a sub 1? What's my first term in the sequence? 3, good. Plus n, we don't know what number term we're looking for, n minus 1. And then d is my common difference, which is 4. So I've got 3 plus n minus 1 times 4. Now, we can rewrite this to make it look prettier. You can distribute your 4 into everything. So I've got 3 plus 4n minus 4. And then we can combine like terms, negative 4 and 3. So nicely, it looks like 4n minus 1. You do not have to do it. You can leave it in the original form. But if it makes you happy to simplify, go for it. All right, so that's our kind of intro into arithmetic formulas, arithmetic sequences. Any questions yet? That's because that's the word you guys know. We put a different emphasis on it. Arithmetic. I guess that's how you would spell arithmetic. I'm really not quite sure. I just have learned that this is arithmetic. So you can call it arithmetic in your head and think of it as plus or minus. Yeah. The next one is geometric, which is a little bit different, and that is multiplying or dividing to get to each one. So an example of this would be like 3, 6, 12, 24, and on. Okay, what am I doing to get from 3 to 6? I told you that we're not adding or subtracting, we're multiplying or dividing. We're multiplying by 2. Now, you might have looked at this and been like, oh, well, we can add 3 to get from 3 to 6. Well, then I would challenge you, well, do you add 3 to get from 6 to 12? And then you would say, no, we don't. So this is true for all of them. You multiply by 2 to get from 3 to 6 and from 6 to 12 and from 12 to 24. Okay, so that means this time we don't call it my common difference. We call it my common ratio. And we say R equals 2. Now, if we're dividing, I'm going to argue that I want you to put it as a fraction that we're multiplying by. So if we were dividing by 2, I'd say that our ratio is 1/2. So we keep it in the multiplying idea. Okay, my formula for this is very similar to the last one, but looks a little bit different. It's still a sub n, so it's still the nth term, equals a sub 1 the first term, but this time it's not plus anything, it's times r raised to the n minus 1. A sub n equals a sub 1 times r n minus 1. So I think so. I've sometimes given them, I've sometimes made them memorize it. This is so like quick at the end that I just want you to see as much as possible. And if you, there's so many different things I'm asking of you in here, so I'll give these to you. All right, and then R is just your ratio, N is the number of term, and then A sub 1 is the first term. So let's do an example with this one. Let's do letter B. So I've kind of already set us up. We know this is going to be a geometric one. Also, the minute you go from whole numbers to fractions, it means that we had to multiply or divide by something, so that means it's geometric. So what am I multiplying or dividing by each time? 1/2, positive or negative 1/2? Negative. I think it's really easy right here to see what my change is. So if I went from 1 to negative 1/2, I had to multiply by negative 1/2. So you don't have to just look at the first one and second one. You can look further down. Maybe these two make it easy for you to see what the pattern is. It doesn't matter. So my R, my common ratio, is negative 1/2. I know it's geometric. And then I'm going to use my formula that we just learned above. It's going to be a sub n, because then I don't know which formula or which number I want, equals, what's my a sub 1? What's your first term? Negative 2. Good. So I've got negative 2 times r, which is negative 1/2, and then raised to the n minus 1. Now you cannot simplify that anymore. This is the best answer you can give. That's not what I wanted. All right. Everybody doing okay so far? N means the number of terms. So we're going to do more with that momentarily. So if I say, and in a second I'm going to do this, if I say find the fifth term, then you're going to plug 5 in for all of those n's. We're going to skip Fibonacci sequence for a little bit, or ever. We're not going to do that. If you are interested, you can let me know and I'll talk to you more about that. We're going to skip letter C because it's kind of like Fibonacci. We are going to go down to 2A. Let's do 2A first. 2A says find the first 3 terms and the 50th term. So this is kind of where we're using our n's again. So like Brooke said, what does the n mean? This is what term we're on. So the first 3 terms mean that we're not just doing a sub n, we're going to do a sub 1, we're going to do a sub 2, we're going to do a sub 3. So these are all my n's. So for like the first one, I'm going to plug 1 in for both my n's. I'm going to find my answer. Then I'm going to plug 2 in for both my n's and find the answer for the second term. And then I'm going to plug 3 in for all my n's to get the third term. So let's see what that looks like. I'm going to do 1 plus 1 over 1. That's 2 over 1, which is 2. Now we're going to plug 2 in for my n's. So I get 2 plus n over 2 equals 3 over 2. You can make that 1.5 if it makes you happy. I don't want to mess with decimal. I'm going to plug 3 in for n. So I've got 3 plus 1 over 3, which is 4/3. Okay. We could keep going, but the one other thing it wants us to do is the 50th term. So we want a sub 50. So I do the 50th term. So I do the exact same thing. I plug 50 in for n. So I've got 50 plus 1 over 50. That's 51 divided by 50. Okay. So what we just found were the first 3 terms of my sequence, 2 3/2, 4/3, and then we like jumped a long way until we found our 50th term, which is 51 over 50. Everyone doing okay with finding those terms? Okay. The next concept we're going to talk about is whether my sequence like goes on and gets bigger and bigger and like goes towards infinity, or whether it approaches just one number, whether it kind of has like a limit, like an asymptote. The words we're going to use are divergent and convergent. I'm going to argue that this one right here is convergent. It's going to go towards one number. Okay. The first number we had was 2. Then we went to 1.5. Then we went to 1 1/3. And then we went to like just barely 1. I'm going to argue that we are converging to 1. Can I get a number smaller than 1 if I plug in a different number for n? Brooke said, yeah, with a question mark, and then was like, no. Well, let's think about it. Let me plug in a big number. What if I have like 100 plus 1 over 100? Well, 100 plus 1 is going to be 101 over 100. Is that smaller than 1? No, it's still bigger than 1, right? It's barely bigger than 1, but it's still bigger than 1. Since I'm taking any number and adding 1 to it, and then dividing by that original number, it's always going to be a slightly bigger than 1. So it's going to get closer and closer and closer to 1, but it's never going to be smaller than 1. It's actually never going to actually be 1. It's going to get close and close and close, but it's not ever going to be just 1. Think about it too. We started at 2, and then we got to 1.5. Well, 1.5 is closer to 1 than 2 is. And then 1 1/3 is closer to 1 than 1.5 is. So we're just getting closer and closer and closer and closer. Now, whenever you have a fraction, it's usually conversion. If you don't have a fraction, it's usually divergent because it's going to get really big. So we're going to skip 2b because it just converges to 0. And we're going to do 3a through d. My first sequence goes 1, 4, 9, 16. I'm basically doing all my perfect squares. Is that getting bigger and bigger and bigger, or is it converging to one number? It's getting bigger. We're going to call this divergent. It's diverging to infinity. It's going to go on and on and on forever towards infinity. Divergent. What about letter B? I do 1/2, 1/4, 1/8. I'm essentially doing 1 over 2 to the nth. Is that getting bigger and bigger and bigger, or do you think it's approaching a number? It's approaching a number. What number is approaching? Whitley? 1. Oh, I don't know if I want to say 1. I think it's getting closer to 0. So I had 1/2, and then I had 1/4. 1/4 is smaller than 1/2, right? And then 1/8 is smaller than 1/4. You might be thinking of something different, Whitley, which is super interesting. We'll talk about that maybe later today, maybe not. But if we were to keep going on, and I went to like the 100th term, that's going to be a very, very small number because it's 1 over a giant number, which will be a tiny fraction, which is close to 0. Okay. These last two are fractions, so they're both convergent. Now, what we know from this is what they converge to. The fraction helps me know what I'm converging to. I want you to only look at the variable and its coefficient. So I've got 3n minus 1 over n plus 2. Ignore the things that you're adding and subtracting, because as I get bigger and bigger and bigger, it doesn't matter if I'm minusing 1 or adding 2 to it. It's still a really big number. If let's say I went to the 100th term, 3 times 100 is 300, and then n, which is 100, is by itself. 300 divided by 100 is 3. These are all converging to 3. They'll never be exactly 3 because I'm still minusing 1 and adding 2 to it, but it's getting super, super close. So what we do is you look at just the coefficients in front of the variables. Same idea for the one underneath it. It's converging because it's a fraction. And this time my numbers are negative 2n over n. What number am I converging to? More? Negative 2. See how there's a negative right there? Negative 2. Other than that, good. We are not going to have time to do limits. So if somebody's super interested in limits or is afraid you're going to see those in college, let me know. We'll talk about them separate. I'm probably going to do that with my juniors because I've got 1 or 2 more days with them than I do with you guys. But we are not going to do limits for you guys as seniors. So skip all the limits, skip all these limits. Okay. Let's see. This one says find the first 5 terms. This is what we call a recursive function. Does anyone do like programming? Has anyone taken a programming class? Have you ever done like a program where like it relies on like a recursive program, right? Where it like relies on the one in front? 3 weeks ago. And you need to make sure that like everything's right because it's got to spit out like the correct line because you use like that answer for the next thing and we use that answer for the next thing. So recursive is that exact same thing, but here it is, and we're doing it by hand. So what I'm doing is I'm using the term in front of it to find the next term. So I give you a sub 1 is 3, and it says find the first 5 terms. So 1, 2, 3, 4, 5. So I'm finding 3. Or so I'm finding all the other terms after 3. I needed 3, though, to find the next term. And I'm going to plug 3 in for my a sub n in this formula that's given to me. So it says a sub n plus 1 is equal to 2 times a sub n minus 5. That means the second term is equal to 2 times the first term minus 5. And then I could go up 1. The third term is equal to 2 times the second term minus 5. So we're just, every time we're putting the next term in there. So first I'm going to do 2 times 3 minus 5. Well, that becomes negative, or 6 minus 5, which is 1. I'm going to use 1 to find my third term. So this is my second term. I have to use my second term to find my third term. I'm going to do 2 times 1 minus 5. That becomes 2 minus 5 is negative 3. Okay. I now use my third term to find my fourth term. So I'm going to do 2 times negative 3 minus 5. That's negative 6 minus 5, which is negative 11. And then I have to use my fourth term to find my fifth term. So I'm going to do 2 times negative 11 minus 5. Negative 22 minus 5 is negative 27. If you think you can find a pattern once you get the first couple of these numbers, go for it. I didn't think I had one, so I just kept using what I was doing. Because it's the next term. So this is saying like n plus 1 equals 2 times a sub n. So let's put some numbers in. Basically, that means a sub, if it's a sub 1, then this would be a sub 1 plus 1, which is 2. So the second term is equal to 2 times the first term minus 5. Same thing if I did like the 10th term. So let's say I had the 10th term. I could find the 11th term by doing 2 times a sub 10 minus 5. Good question, bro. All right, we're going to skip these. If you want me to do those on a video later, I will. Or if you want to do those during office hours, I will. But we're going to skip those for now. We're going to jump to number 5, and it says consider the sequence. Find the common ratio or difference, find the 8th term, and find the explicit rule. So we're going to do one, or letter A and letter E. Hint, there's one of each, just because we don't have time to do all of them in person, so we're just going to do one example of each one. Okay, so I've got 3, negative 1, negative 5, negative 9. Is this arithmetic or geometric? Good. How do you know? There's no fractions. Also, I'm adding or subtracting. Another easy sign is if there's negatives and it doesn't alternate, then that means it's adding or subtracting. So once I hit negatives, I'm like down in the negatives when you're adding or subtracting. What number am I adding or subtracting to go from 3 to negative 1? Yep, minus 4, minus 4, minus 4. So my common difference is negative 4. Let's write my general form of the equation, my explicit rule. So remember that the equation goes a sub n equals a sub 1 plus n minus 1 times d. So for my general term, I don't have a sub n, but I do have a sub 1. What's the first term in this equation? 3, good. Plus, we don't know what n is. And then my common difference is -4. You're welcome to leave it like this. You're welcome to multiply it out. I'm just going to leave it like this. So we found the common difference. We found the explicit rule. The last thing we need to do is find the 8th term. So this is where we use the n's. So instead of writing a sub n, I'm going to write a sub 8. And instead of writing n minus 1, I'm going to write 8 minus 1. My a sub 1 and my d are the same as my equation. I just am doing my work over here so all my answers go in the same line. So my a sub 1 was 3, you told me a minute ago, and my d is -4. Don't do anything with the a sub 8, just leave him by itself, and I'm going to add 3 to 8 minus 1 times -4, and I'm going to get my answer. So I get 3 plus 7 times -4. So that's like 3 minus 28, which is -25. So a sub 8 equals -25. Okay, now we're right at time, but can we do one more before we go to lunch? Let's do letter E. You guys ready to move on from letter A? Okay. Letter E is a geometric one, so if you're ahead of me, go ahead and go look at letter E, figure out what your common ratio is. I already told you it's geometric. See if you can remember the equation. The whole answer, so we had to find the common difference, which is the first one. We had to find the general rule, which is the third line, and then the last one was our actual answer. Oh, you done with that? Yeah. Perfect. I started scrolling away. All right, what's my common ratio here? 1/8, very good, Whitley, times 1/8. I'm dividing by 1/8, and it's positive. I don't see any negatives here, so it's positive 1/8. R equals 1/8. Remember my formula here goes a sub n equals a sub 1 times r raised to the n minus 1. And so we just plug in. So a sub n we don't know. A sub 1 is what? What's my first term? 8. Good, my common ratio is 1/8, and I raise that to the n minus 1. And then the last thing says find the 8th term. So I'm going to do a sub 8 equals 8 times 1/8 raised to the 8 minus 1. Oh, there's a lot of 8s in this problem. Now you can use a calculator, but I don't have one readily available. So I'm just going to do this using my exponent rule. So just kind of a easy way of thinking about it, even though we normally just throw things in our calculator. 8 minus 1 is 7. So I've got 8 to the 1/8 raised to the 7th. You have to do 1 to the 7th and 8 to the 7th, which is 1/8 to the 7th. And then I can think of 8 as just 8 over 1. If you remember back to like the very beginning of the year where we did exponent rules, if I have a term on top and then a term on bottom, you can minus their exponents, or we can kind of cancel out. I see that I've got an 8 on top and 7 8s on the bottom. So if you get rid of one of those 8s, we're left with 8 to the 6th. So my final answer here would be 1/8 to the 6th. And again, you can put that in your calculator, but that's like some weird decimal or some 1 over a really big number, which might not make a lot of sense. So I think it's easy to think of it this way. All right, when we come back from lunch, I have like 1 or 2 more problems, and then I want to do some 9-5. So let's go to lunch now. I think it's 12:17 is when I want you back. That's your 30 minutes, right? All right, I'm going to stop the record so you guys don't have to